It's page 64. So I put the steps on the front, but I'm also going to walk you through an example on the front and what it exactly means. And then I don't know that you necessarily always need step by step, but it's there. Okay. So step one is to write the polynomial inequality. It's an inequality because there's not an equal sign, right? In standard form. So it's a form where the right-hand side is 0. And then you need to, if it's not factored, you need to factor it. You may need to factor a couple of them, but this one is factored for us. Then we find all the real zeros, okay? Real zeros, because it may have other solutions that you can't find. We're only concerned with the real solutions, not the imaginary solutions here. And is that a pretty easy thing to find from the factored form? Yes, okay? So this would give me a 3, a 1, and a -4. It's -4, 1, 3. It's always helpful if they're in order. So there are my zeros. Now we're going to plot the zeros on a number line. So that's what we're going to do under step 3 here. So I just want you to draw a line. Draw it kind of long. Don't draw it super short, and don't make your numbers really close together because it's going to cause problems for you. I know some of y'all like to draw teeny tiny things, but this is a number line. It's not an axis. It's just a number line. So I'm going to make number 4 right here. -4 right here. I'm going to put 1 looks good about right here. 3 about right there. Then it says, when we plot the points on the number line, we got to have either solid points or open points. So since this doesn't have the equal to, my 3 zeros here are all open circles. And those zeros are the only places that the polynomial can change signs. So we're trying to figure out where this graph is positive or negative without actually looking at the graph or having to graph it. Okay? So we can do that by looking at the signs here. So step 4 says choose a test number that is easy to compute with in each interval. We're going to substitute the number in and just determine the resulting sign. We don't really care about the number. We just care about the sign, if it's positive or negative. We're going to construct a sign chart showing the sign of the polynomial in each interval. All right, so let's pick over here on the left-hand side of this. We're going to pick -5, right? So if I take -5, there we go, and I plug it into here, right? -5 minus 3, is that going to be positive or negative? Negative, right? So that's negative. -5 minus 1 is still negative. -5 plus 4 is still negative. Whatever the numbers are, I'm going to have negative times negative times negative. Does that make sense? And if I multiply negative times negative times negative, what do I get? Negative. So in that part of the interval, it's negative. That's all I care about as a sign. So then in here, I'll pick an easy one. Let's pick 0, right? So 0's in here. If I plug in 0, that would give me negative, right? Plug in 0 here, I would get negative. Plug in 0 here, I would get positive. So negative times negative times positive is positive. Everybody with me? Only looking at the signs. So between 1 and 3, I'll plug in a 2. If I plug in 2 here, what do I get? Negative. If I plug in 2 here, I get positive. And then the last one would be positive. Okay, so negative times positive is negative. So then I'll plug in a 4 for that part of it. Plug in the 4, I get positive, then what? Positive, and then positive. So when I multiply positive times positive times positive, I get what? Positive. Right? All right, so then I got to decide which one I actually want, right? What parts I actually want here. When I look at this, I want all this to be less than 0, which means it's supposed to be negative, right? So the solution to this is everywhere that I would get a negative when I do this. So that would be this part here. Shade all the negatives. Not this part, but this part here. So there's my answer graphed on a number line. Okay, you with me on that? Everybody understand where that came from? Okay, so we chose our test number, we substituted it in, we constructed our little sign chart there, and then it says from the sign chart, shade the parts of the number line that satisfies the inequality, then write down the solution of the original polynomial inequality. Okay, and it should say in interval form. So that means that all of the x's from where? Where do I start on the left? Negative infinity to what? Negative 4, right? I never include the infinities. Do I include the 4? No, because it is an open circle, right? Then I also have this part right here that goes from 1 to 3. Do I include either one of those? No, because it was an open circle. There's my solution. This is my solution in interval form. This is my solution graphed on a number line. Okay, we all good? Only concerned about the signs. Okay? All right, awesome. So let's do another one. So it says, show the solution of each polynomial inequality on a number line and an interval notation. So there it is. It's already written in standard form for me. It's already all factored beautifully. So what are my zeros? 0, 1, and negative 3. So negative 3, 0, 1. Then my number line. Right, so here is negative 3. Is 0. Here is 1. So are these open circles or closed circles? Closed. All right, so I'll start over here with a negative 4. If I plug in a negative 4, this would be negative. What would this one be? Negative 4 minus 1 is negative. And this would be negative. So negative times negative is negative. Okay. Any questions about where any of that's coming from? It's not magic, but it's not hard because I don't have to use the numbers, right? So then I'm going to start here. I'll use negative 1. So negative 1 would still make that first one negative. Negative 1 here would make this what? Negative. Negative 1 here would make this positive, which means that when I multiply those together, I get positive. All right, so then in here, I'd have to use like 1/2, okay? So a positive 1/2 would make that first one positive. Makes the second one what? Positive 1/2. What if I plug it in here? What do I get? Negative, and then positive, right? So overall, that is negative. Then I can plug in a 2. Positive 2 would give me positive in the first one. It would give me positive in the second one. And it would give me positive in the third one, which makes all this positive. Now, what do I want? For this to be positive or negative? Positive, because all this is supposed to be greater than or equal to 0. So this is positive. I'm looking for everywhere the function is positive. So I shade this, and I shade this. Remember, the number line and the interval are both parts of your answer. So from negative 3 to 0, do I include either one of those? Yes, both of them, right? And then from 1 to what? Infinity. Do I include both of them? No, just the one. Everybody good? Any questions? Easy enough? Because this is a part we're getting pieces together to be able to do parts of some other things coming up. All right, so we're going to do this next one together, and then I'm going to let you do one on your own. All right, so it's already written like it's supposed to be, so I can just find my zeros. What are my zeros here? 3 and negative 2. Okay, so negative 2, 3. Right? Here's my number line. Open or closed? Open. So here I have a leading coefficient that is negative. So it's going to have a negative multiplied by it before I even worry about plugging anything in, right? So even though I'm only plugging things in into 2 places, I'm still going to have 3 signs here because I have to take that into account every time. You with me? Okay, so we'll use negative 3, right? So I have to get that negative from here. Then negative 3 minus 3 is still negative. Negative 3 plus 2 is negative, but then I square it, so what happens? It's positive. So basically, every time here, the first sign is negative and the last sign is positive, because if you square it, it's going to be positive no matter what. Make sense? So here I'm going to use a 0. Negative, because it's coming from there. When I plug in 0, I get negative. And then when I plug 0 in here, this is going to be positive. Oh, I forgot to look at this. So negative times a positive is a positive. This is also positive. Okay. Then when I plug in 4, I know I have to start with a negative because it comes from there. Then this is positive, and this is positive. So overall it is negative. Now what do I want this to be, negative or positive? Positive, because all this is supposed to be greater than 0. That means this, I'm looking for a positive. So I shade this, and I shade this. So is my interval from negative infinity to 3? No, it is not, because those are open circles, right? So I go from negative infinity to what? Negative 2. Both are parentheses. That's a union with negative 2 to 3. Now I want you to look at something else. And you should have some room either right underneath where we did this or right to the right of it. Like if you don't have any room over here, you probably have a little bit of room down there. Let's think about this from a sketching perspective, like we did the other day. I already have my zeros, so that's at, we're going to sketch this graph. This is at negative 2. This is at 3. So this is actually my x and y axis, where that's just a number line, right? And this is at negative 2. This is at 3. What is the degree of that polynomial? 3. So the degree is 3. And it's a negative odd function, so my end behavior looks like this, right? Yes? When I go to sketch this, anything special about either one of these? This is the negative 2 is a double root. So what happens at a double root? It bounces. Okay, so I'm going to have a bounce right here. So when I go to draw this, it looks like this. I'm going to come down. I'm going to bounce here. Oh, I should have found my Y-intercept. Let's see, what is my Y-intercept? It is negative times negative 3 times what? This one times 4, because it would be 2 squared, right? So this is going to be positive 12. So I'm up here at 12. When you graph it, no. That's a good question, because we're graphing it, right? And that's the difference here. That's what we're going to look at here. So this comes, it bounces off, it comes back up, and then it's going to come down. Ugh. One of these days I'll learn how to hit the points. Probably not. I can hope. There we go. So it looks something like that, but not really a point of inflection. That kind of looks like that's what I was doing. That's not. Okay. Now, I can kind of get the graph. I can kind of get this information from that. This is why when we talked about positive and negative intervals when we were looking at functions, remember how you knew that it was positive right here, like it's pretty obvious, but you can't include the zeros, and that got confusing because sometimes we did, sometimes we didn't, like for decreasing, things like that. You can't include the zeros because it's not positive. The other ones, the positive does not include 0. If it is greater than or equal to 0, then that means it's equal. It doesn't mean it's all positive. It's positive and it's equal to 0. So if I look at this, I can't just say, oh, it's positive from negative infinity to 3, because it's not, because I don't get to use those, because that's why they're open circles. Does that make sense? So you can get it from the sketching if the sketching makes sense to you, but you also need to be able to do it this way. Okay, so if you want to sketch them and get them, but at least half of them have to be done purely with this right here. This might not be a bad idea to kind of, check yourself or whatever, but just make sure that you don't do this on every single one of them if you do it on any of them. Okay, we good? Yes? All right, I want you to try the next one on your own. You don't have to graph it. You can if you want to also, but I do want the sign chart. Okay, so work on number 3. Get the little sign chart for me. All right, so I've got, let's see, negative 4, 1, and 2. So here's my negative 4. Here's my 1. Here's my 2. These are all closed circles, right? So if I plug in negative 5, this is going to give me negative, negative. The third one has to be positive, so that makes this positive. If I plug in a 0, we get negative, positive, positive, which is negative. If I plug in 1/2, then that's going to give me negative, positive, positive, which is negative. And then if I plug in 3, I'm going to get positive, 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 which is positive, right? So I want, it's supposed to be less than or equal to 0, so it needs to be negative. The whole less than or the equal to part, that's taken care of by my solid circles here, so I don't have to worry about it so much as if I would with the graph. So I'm looking for negative, which means it's here to here. So do I have to split that into 2 intervals? No. Would I have to if they were open circles? Yes, but this just goes from -4 to 2. Then let's just sketch this real quick. So I'm here at -4, here at 1, and at 2. See, my y-intercept to be -2 times 4 times +1. So oh, shoot. Thank you. Yeah. It's like, oh, I don't know, did I? Yeah, -4. All right, so, but I do get a -8 for my y-intercept, right? I'm pretty sure I do. Okay, this, what is the degree here? 4. It's even, leading coefficient is positive, so my end behavior looks like this, right? Anything special going on here? Bounce right here, right? So I'm going to bounce right here at the 1. So I'm going to start up here at the, come down. Remember, I have to go through the -8, but it's not necessarily a minimum. I'm going to bounce at the 1, and then something like that. I don't know how far down it goes. That's what it would look like. So when we're looking for negative, I can see that it's negative from negative and including 0. That's why I can go directly through there. I think you're safer with this in the open and closed circles so that you don't get the whole positive and negative interval, not including 0 thing. That was throwing some of y'all off at the beginning. We all good? All right. Last one. We're going to do this one together because this one's a little bit different. Now, this is set equal to 0. Is it in fully factored form? Look at this. If it's fully factored, you're supposed to divide or factor out all of the negative coefficients, right? So I still need to factor out a -1 from here. Does that make sense? So I'm going to rewrite what I have. I start with negative x minus 1. I'm going to factor out a -1 from there, so it comes out here, right? Then that becomes x minus 3, like what I need, times x plus 2 cubed is greater than or equal to 0. Now what happens to the negative? They cancel out. So I really just have x minus 1 times x minus 3 times x plus 2 cubed is greater than or equal to 0. So make sure you actually look at what you have before you just assume that it's in the form that you need and just go with it. Okay. All right, so then from there, my zeros, I'd have a -2, 1, and 3. Draw my number line. -2, 1, 3. Open or closed circles? Closed. So remember, I'm using this one right here, not the original one there, because I had to fix it. So if I plug in a -3, that would make that negative. -3 would make that negative. When I plug in a -3 here, what happens? Positive or negative in the end? Negative, because -3 plus 2 is a -1. Then when you cube a negative, you still get a negative. So overall, that one right there would be negative. When I plug in 0, right? Negative, negative, positive. When I plug in 2, I get positive, negative, positive. So that would be overall negative. And then greater than 3, so 4, positive, positive, positive. What we've got there. Greater than or equal to 0 means I'm looking for positive. And I've already taken care of the open and closed because of the circles that I put down here. So I want this part and this part. So I go from negative 2 to 1. Do I include those? Yes, I do. And then 3 to infinity. Any questions? Not that bad, right? This doesn't take that long. Okay, but it's important. Okay, good deal. Go ahead and glue that in. I'll get you your homework.